Hi everybody, I'm Miss Cooksey. Today we're going to be talking about an introduction to quadratics. So we're going to talk about the three forms of quadratics, their shape, and how we calculate different pieces of quadratics. This is going to be a two-part video. The first part of the video, we are going to talk about the different components in a quadratic graph. And the second part of the video, we're going to be trying to graph a bunch of quadratic graphs based on some information. So let's go ahead and get started. So the first thing that we need to know is that quadratic functions can be written in three forms. There's three different equations that we can use to write about quadratic functions. And I'm going to apologize in advance. I'm using a stylus situation today, and it might not go as well as I was hoping for. So the first form of a quadratic function that we are going to learn is standard form. So standard form is f of x equals ax squared plus bx plus c. F of x equals ax squared plus bx plus c. We can get all the information we need to out of this graph in standard form, but sometimes it's a little bit tricky. Vertex form is all about the vertex. So the vertex is going to be the tippy-tippy top or tippy-tippy bottom of a parabola or the shape of a quadratic graph. And in vertex form, our function is going to be f of x equals a times x minus h squared plus k. In this equation, h and k are the vertex, and we'll see that definition in a second. H and k are the vertex. Oops, let's erase that. Finally, we have factored form. Factored form is going to be f of x equals a times x minus m times x minus n. And this is the form when we factor our standard form. So we have these three different forms that we can use. All of them are good for different things, and over the course of the next few videos, we'll talk about what each one is useful for. So let's go ahead. I'm going to scroll down a little bit. Now that we know our three forms, we're going to look at the shapes of a quadratic function. So the shape of a quadratic function is what's called a parabola. So the shape is a parabola. It's a U shape. So while a linear function makes an L shape, or a straight line, an exponential function makes an L shape, a parabola makes a U shape. So parabolas can be facing upwards or facing downwards. So let's graph this graph. We have a point at 0, 1, a point at 1, negative 2, a point at 2, negative 3, 3, negative 2, and 4, 1. So this would be a parabola that opens upward. Then our next parabola, we have a point at negative 5, negative 2, negative 4, 1, negative 3, positive 2, negative 2, 1, negative 1, 2. This is a parabola that opens downward. One interesting thing about quadratics is that we can actually predict which direction a graph is going to open by the shape. So, by the equation. So, if the a value in the equation is positive, my graph is going to open upwards. If the a value in the equation is negative, my graph is going to open downwards. And you can see above, each of the three forms of the equation has an a value. So ax squared plus bx plus c, a times x minus h squared plus k, and a times x minus m, x minus n. This is what we're talking about when we say the A value. So if it's positive, it opens upward. If it's negative, it opens downwards. The last piece of information about the pieces of a parabola that we need to know is that parabolas are always symmetric. That means we can split them directly in half vertically. And they are symmetric around a central line called the axis of symmetry. So the axis of symmetry is a special line that divides the parabola in two, and it's always in the equation x equals something. That's because in vertical lines, the x value never changes. So let's look at each of these parabolas and write the axis of symmetry. So in this example, let's change the color to purple. The axis of symmetry goes straight through where x equals 0. So that's my axis of symmetry. Here, the axis of symmetry divides the parabola where x equals -2. And here, the axis of symmetry divides the parabola where x equals 3. So this is how we determine our axis of symmetry, drawing a line and figuring out what the x value is at that vertical line. The axis of symmetry, where it intersects the parabola, that is a special point called the vertex. So a maximum vertex, I'll go back to my black pen, is the highest point on the graph. While a minimum vertex is the lowest point on the graph. So if its graph opens downward, if A is negative, it's going to have a maximum. If the graph opens upward, so if A is positive, it's going to have a minimum. So let's look at these graphs and we're going to come up with the answers to these pieces. So the first thing we need to know is the axis of symmetry. So we can draw a straight line up and down through our graph. And that axis of symmetry is x equals -2. My vertex is going to be where the axis of symmetry crosses the parabola, which in this case is at -2, 0. Also, because my graph opens downward, that vertex is the highest point, so we know it's a maximum. Now for domain and range, this is going to be a little bit of a review. Domain, we look from our leftmost arrow to our rightmost arrow. So the leftmost point here is an arrow, that means -infinity. Our rightmost point is an arrow, that means +infinity. So our domain is all real numbers, or -infinity to infinity. And our range goes from bottom to top. So our bottommost points are arrows. Our topmost point is where y equals 0. So our range goes from -infinity to 0. Let's do one more example. Here we're going to make another axis of symmetry. So this time we're going to draw our line and make it thinner. I didn't like how thick that last line was. That'll work. So here's our new axis of symmetry. This time the axis of symmetry is at x equals 2. The vertex is going to be where the axis of symmetry intersects the parabola. So that is at 2, -4. The graph opens upwards, so we know that that vertex is a minimum. And again, the domain from left to right is arrow to arrow, so it's going to be all real numbers, or -infinity to +infinity. And our range is bottom to top, so this time the bottom point is at -4, and the top point, let's move my face, is at infinity. Thanks for watching. Be sure to watch for part 2, which will come up right after this, so that you can finish up your notes for today. If you're in my class, make sure you subscribe so you don't miss a video, and I'll see you next time.